take a look at how to graph an exponential function. So the first function we're going to look at here, y equals 2 times 3 to the x. Since the base for the exponent is bigger than 1, this means I would expect this function to be exponential growth. So it should look something like this when we're all done graphing. I'm going to start by finding the y-intercept, and then I will plug in my chosen value for x, whatever value that I decide, to find a second point. So we'll graph 2 points on this. We will graph 2 points on this graph. We'll plot 2 points for this function. Remember, you can always graph a function by making a table, a little xy table, just like you did in middle school, okay? So if I'm going to start with the y-intercept, then I'm going to plug in 0 for x. If I plug in 0 for x, this means I've got 2 times 3 to the 0 power. Anything to the 0 power is just 1, so this would be 2 times 1, which is just 2. So my y-intercept is at 2. So I'm going to plot that point right there. And then I'm going to pick another value for x to plug in. You can pick to plug in anything that you want. You can pick a negative number, you can pick a fraction. I'm going to pick something that seems easy to me, so I'm just going to plug in 1. So that would give me 2 times 3 to the first. 3 to the first is 3. Remember, order of operations as we evaluate that exponent first. And then 2 times 3 is 6. So the other point on my graph would be 1, 6. If I wanted to have some more points on my graph, I could pick in more. I could pick more values of x to plug in. I would get a better picture of my exponential graph. But this is going to look something like that. So this is an exponential growth function. We can graph an exponential decay function the same way. So here I've got y equals 6 times 2/3 to the x. This, since the base for my exponent is less than 1, is going to be decay, exponential decay. So I'm going to expect my final graph to look something like this. I'm going to treat this the same way. I'm going to pick some values for x to plug in and see what I get for y. And I'm going to start just like I did before by finding that y-intercept, which means I'm going to plug in 0 for x. So when I plug in 0 for x, I would have 6 times 2/3 to the 0 power. Remember, order of operations, evaluate that exponent first. 2/3 to the 0 power is just 1, so I've got 6 times 1, which is 6. So I have the point 0, 6 on my graph. There's my y-intercept. And now, again, you can pick any value you want to plug in for x. You could pick a really big number, a really small number. Fractions are fine. I'm going to, again, just choose 1. So when I plug in 1, I would have 6 times 2/3 to the first power. So when I take 2/3 to the first power, that means 2 to the first over 3 to the first, which would just give me 2 over 3. So I have 6 times 2 over 3. We know that when we multiply fractions, we can reduce here if possible. So 6 would be 2 times 3, and I could reduce my 3's. So I'm left with 2 times 2, which would be 4 over 1, or just 4. So my other point on this graph would be 1, 4. Again, if I wanted more points, I can plug in more values for x to find more values for y. But from those 2 points, I see my graph is going to look something like this.